We often find ourselves in a world where we have to look up a conversion from one unit measure to another. You want to convert from, say, degrees Celsius to degrees Fahrenheit, or number of tablespoons to numbers of cups. Google's got this fantastic ability to do automatic conversions combined with the ability to do calculations. A lot of people don't know this, but you can go to Google and just do basic calculations very, very easily. I'm going to show you how to do that in this lesson. The general pattern for doing units conversions is this one you see right here. From units to units, you use the pattern number units in units. What I mean by that is something very simple. So here we see a very simple conversion. I can go to Google and type 212F in C. Let me show you real quick. If I go to Google and I type 212F in C, you'll get the conversion from Fahrenheit to Celsius. So in this case, the boiling point of water in Fahrenheit is exactly 100 degrees Celsius. That's pretty straightforward. Let's try another one. 400 yards in miles. I don't know about you, but I can't do that in my head easily. So I can come to here and type 400 yards in miles. And it will show me the conversion instantly. You're getting the idea. I use a number, like 400. I use the unit measure name, like yards, inches, centimeters, whatever. The word in, and then the other unit, the destination unit, that is what you want it to be converted into. So for example, here 32 C and F. You know what that's going to be. That's going to be 0. Rather, it's not going to be 0. It's going to be a rather warm temperature. In fact, let's try it. This is why you want to do this kind of thing. 32 C in F is going to be 89 degrees Fahrenheit. A little warm. You see why this is handy? If you travel to Europe, you have a European cookbook, for example. Now you can do the conversions from one unit measure to another. What other kinds of measures could we do? We can do 23 bushels in quarts. I have no idea how much a bushel is, but if I do this conversion, it will tell me. So let's give it a shot. 23 bushels in quarts. In that case, 856 quarts. A bushel is fairly big. If you want to get an exact idea of that, I would say 1 bushel in quarts. And that will tell me 1 bushel, that is the traditional measure of volume, is 37 quarts. This is a fantastic ability. I can convert units I know to units I don't really understand. Angstroms are a measure of very, very small units, usually used for microscopes or electron microscopy. You measure things in angstroms when you're trying to talk about silicon chips. So 1 inch in angstrom, it's a quarter of 254 million angstroms is 1 inch. So you can see it's a very, very tiny measure. Now, one thing to notice here is that if you're converting an illegal measurement to another illegal unit, for example, you're trying to convert centimeters to milliliters, Google won't tell you you're doing something dumb. It just won't make the conversion for you. Let's try that so you can get an idea for what it's like. 23 centimeters, which is a distance in length, in milliliters, which is a measurement of volume. Doesn't make any sense to convert length to volume. So it just doesn't give you a conversion. It doesn't make any sense to do that. So now you see the idea. You can do all kinds of stuff. For example, I swim 500 yards. I want to see what that is in miles, and I can see what that is immediately. Now, conversions can also be useful for things other than purely scientific and mathematical things. You've probably read the book 20,000 Leagues Under the Sea. What does that title refer to? 20 leagues in miles. And you can see that the 20,000 leagues in miles is 69,000 miles. That's a long way. That's not the depth to which the submarine goes in that book. It's actually distance measure that it travels in the course of the novel. We can also do somewhat more sophisticated, or at least cosmopolitan kinds of conversions. I can ask questions like, what's 280 euros in US dollars? And I will get the financial conversions of the moment. So you can see here there are the normal disclaimers about you shouldn't use this for automatic updates for monetary transactions, but it gives you a pretty close to real-time sense of what the conversion rate is. So right now, if you want to get just a simple conversion rate, €1 in USD, and we can see it's 1.25 US dollars. You get a great sense for that. So that's the cosmopolitan world traveler kind of conversion. What if you want to do something more home kind of a conversion? So I can imagine wanting to do an upscaling of the chocolate chip cookie recipe that requires, say, 5 tablespoons of sugar, but I need how many cups if I'm going to multiply that by, say, a factor of 4. So I want 20 tablespoons in cups. So rather than counting out 20 tablespoons, I know I can just get 1¼ cups of sugar and do the conversion very quickly on my laptop sitting in the kitchen. We can ask a lot of other questions. Now, as we saw in the last lesson, population of Japan is one of those questions we can ask very, very easily. One of the really nice features here is that you can then click through this graph, which shows that it's now 127 million roughly. But if we click through here, what we'll do is end up on a data exploration page. In essence, what we've done is gone from looking at just the raw data, just the single number, and now I can start to look at things like the transition, the change in the Japan population over time since the 1960s. There are other ways to explore this data very easily. For example, I can click on this tool right here, which is a bubble chart, and it will load in comparable nation states. So for example, here's Japan right there. There's another country, Indonesia. There's another country down here, and so on. Now what's nice about this is the whole data set is loaded, and if I hit this button right here, this will play the data over time, and I'm going to pause it for a moment and say, what country is that? Unsurprisingly, it's China. So you can see the relative growth rate in the data by doing the simple play visualization. There's a lot of data in here. I'm not going to spend the time right now to go and explore all the different options, but I do want to give you the sense that there's many different ways to view this data, many different ways for you to explore it, and it's all here easily available to you. There's other kinds of things we can do. We can, for example, answer simple calculator questions like 1 plus 2. And it would help if I go to the regular Google search page, 1 plus 2 here, and we get simple calculations like that. That's a fantastic thing when you're doing simple additions or subtractions and you're trying to do a checkbook or something very quickly, you happen to have it there. I can very quickly do complex calculations like 23 divided by 45 times 121. I can do those simple calculations there. There's a lot of functionality built in here. A simple one might be 12% of 124, which computes it for you very, very quickly. So you see the idea. There's a Google calculator built in, and there's a bunch of capability here, including just truly some fun things. So here's what we call an Easter egg. The number of horns on a unicorn is unsurprisingly 1. But what's really fun about this Easter egg is I can now start to add additional expressive values like the loneliest number. And I discovered that the number of horns on a unicorn and the loneliest number is 2. Who knew? In any event, there's a lot of capability here that you might not have known about. So if I do something like an algebraic expression like x squared or x raised to the 2 power here, I get not just information about x squared, but also a graph of that function. So if you're doing high school algebra, this is kind of a nice thing to be able to do. I can also add additional functions into this graph simply by separating them by a comma. So I insert a comma there, and now let's add another function like sine of x divided by x. Divided by x, there we go. Now you can see here, I've got this function, which is the x squared function in blue, and this sine of x divided by x in red. But I don't see much variation here, so what I would like to do is to zoom in. So I'm going to zoom in some more, And you can start to see what I'm doing is I'm changing my units. So now we're looking at this from 0 to 10 on the y-axis and 0 to roughly 1.7 on the x-axis. Imagine doing this. So there we've got sine of x, cosine of x. You see, I can now start to visualize the relationship between those very, very easily. The graphing capability actually also extends into other dimensions. So I could do something like x squared plus y cubed. Here I'm seeing a beautiful 3D image of this complex function, x squared plus y cubed. As we saw before, we can actually then look at different values on this graph and start to get a sense for it. And these same capabilities of zooming in, zooming out, or automatically rotating hold as well. So this is fun if you're doing algebra or schoolwork, but let me show you another use for this kind of thing. You can imagine that you want to understand something like the effect of compound interest. So compound interest is simply interest that you keep compounding on each payment period. And the formula for that is well known. So if I wanted to, for example, understand how much I would end up paying over the lifetime of a loan, I might want to ask a question like this. I'm going to do another Google calculation. 100,000, so that's the amount of, that's the principal on the loan. I'm going to then take that and multiply it times 1 plus the interest rate, which I'm going to say is, say it's 3%. Right? And then I multiply that, I raise that to the exponent, which is the amount of years that it's being invested. So in this case, I'm going to use x, because what I want to do is to see the effect of changing this interest over time. So here, what we've got is a chart of this function over time. Of course, it doesn't make any sense for us to try to compute interest that is for negative 2 years. So let me change this expression just slightly. I'm going to add the condition from 0 to 15. This means from 0 to 15 years. And you can see it only starts to make sense here about 1 year out. And if you look at the y value up here, watch that number. As I move the cursor over the graph, that number will change. So you can see here at 1 year, you're paying about $1.35 $100,000. So that's the whole accumulated cost. On the other hand, if you go out to 6 years, it's going to be about $1,100,000 and so on. So let's change that interest rate from, say, 3% to, say, 15%. And now you start to see something interesting. So now you can compare those two values by taking that simple function and plotting it as a function over time. What I want to give you the sense for in this lesson is that the Google Calculator has a wide range of things it can do. You can calculate the mortgage payments over time, you can get that accumulated interest and see what the total value is very, very quickly by typing a single line and exploring that data value by using your cursor. On the other hand, there are a lot of very, very simple calculations you can do to, for example, look at functions like x squared, or you can do conversions like the number of tablespoons you need for that chocolate chip cookie recipe. Multiply that cookie recipe by 4, and you don't want to add 25 tablespoons, but maybe 1.5 cups. You can get those conversions very, very simply, and this is a great way to do it. Test out some of your skills in the next exercise.